track that down, I used to consult with Qualcomm, so I know the history of how the volume went up. It's tremendous. That's what the driver was. So it's a confluence of all of these three that has really caused us to take off. So it was enabling the first internet experience, first computing experience. I don't know if you've traveled to faraway places, but in Brazil in 2001, I saw more internet cafes by the Amazon River than I've even seen in the United States in that time frame. So since then, now that there are smartphones, people anywhere can access the computer. They can do Google searches, Bing searches, wherever, whatever you want to do. It's a level playing field. So, I mean, even in my business, I'm a consultant, right? So one of the consultant's biggest value add is information and knowledge. Well, if 80% of that knowledge is available to anybody, all you need to do is what you're going to search, right? So life changes for everybody and anybody because of this. But I think we're all on a higher level, and I think the opportunities are to get contributions from around the world. So I view that as a positive. You're connected anywhere, you're situation aware, location aware, so people are, this is where the sixth sense is getting built into the phones, and there's just more and more of that. This is a quote from the CEO of Qualcomm, Paul Jacobs. It was the largest platform in the history of mankind, and his rationale was, you know, there's 6 billion people in the world, over 5 billion phones. Tell me another device that there's 5 billion out there. The shoes and toothbrushes and things like that, right? Nothing high tech. So this really is a very, very huge platform. Now, there's other things coming up, like the new paradigm that we'll talk about now is the CO sensors, the chart from yonder by that says that with mobile computing, with cloud computing and data centers at the hub, surrounded by a sea of sensors all around, that could be the next big thing, right? And I think you saw a little bit of that with Professor Yonder Spiegel, and I'll certainly support that also. Anybody know how many sensors in a iPhone 7 or a Galaxy 7? I actually don't know the number either, but I would guess it's about 30 different sensors. Sensors always interface with, most often, with analog interfaces. So that analog information has to be converted to digital if you want to do any kind of processing. So somebody had asked about analog designer, what kind of things you got to do. Certainly you got room. That's not going away. Startup opportunities, huge opportunity here, I think. If you can think of a solution that somebody has a problem and you've got a solution that nobody else has, good place to start thinking about a startup. Now, if you've never done a startup, get help from somebody, right? I mean, that's the kind of thing that I do for people that come to me, but and I'd certainly be glad to answer questions even when I'm back, but this is just a huge, huge area. We'll talk some more about it. It can be in the digital home, it can be in transportation, it could be healthcare, all kinds of opportunities. Problem is a lot of people are working on it already. Doesn't mean that you can't think of solutions, right? And so I'm going to run through a lot of material here that, you know, some is maybe actually repetition, but the purpose of this chart, again, this is from ISSCC, let's see, last year. And what this is saying is that, yes, we've looked at IoT, IoE, IoT, really, Internet of Things, and there's lots of devices, but look at how many apparel items there are, so many more, and you could actually conceivably have some kind of a sensor on any one of these devices. So the market is just huge. One thing that, by the way, people don't talk about in the Internet of Everything and Internet of Things is that these devices if you have to have a sensor on here, it's got to be very inexpensive. So while your volume of your chips could go up, number of chips could go way up, the revenue for a company shipping that may not go up that much, right? So you just got to watch that. The press doesn't talk about it, but certainly that's what's going to make the business work. So what are you doing with all of these things? The smart objects are getting smarter. They have to be connected through networks. They have to be connected through data centers. And you need designers for each of those things. You got to have designers here. You got to have designers here. So I mean, when I say I'm excited about the opportunities, they're just huge. You can figure out where you want to play in this whole space. It's wide open. I think he showed you this example, 50 billion connected devices by 2020. We're almost there, right? 3 years away. The overall summary, mobile devices now outnumber people. Over 90% keep their cell phones within reach 24/7. Can you do without a cell phone these days? Probably not, right? And this just become part of life. And then they got to be smarter. In 2 years, we need a better one. So it just keeps the industry going. As long as the demand is there, industry's going to keep going, right? Okay, so you can look at some of the drivers. I think some of this data could be a little old, but demand is very much there. Bottom line in all of this, though, is the demand for the chips is there, and what it's causing is a huge data explosion. I think the latest data I saw was like 10 times this already. 100 exabytes. Anybody know how much an exabyte is? Come on, you guys ought to know this. It's 10 to the 18. All right, terabyte is 10 to the 12. Exabyte is 10 to the 18th bytes per month. Huge amounts of data. How do you process that data? You need processors that are smart enough, that are low power, that can function at high speeds in your devices locally. Challenges are there. Don't tell me that there's no challenge for electrical engineers here. It's just tremendous. And I don't see any end to it. It may not all be Moore's Law, but we'll talk about alternatives, right? So it's okay. The internet is severely challenged. Lots of mobile devices, lots of Internet of Things, lots of data. It's just exponential. No matter where chart, you can do a search yourself. You'll find all kinds of information on how challenged this is. I find this one interesting. This is from 7 years ago, ISSCC keynote speech. Greg DeLoggy was talking about showing a multiprocessor and each of the areas, whichever area you pick, wired external cable connectivity. I don't know if you can read this on the back, but everything was going to go up by a factor of 10. So here we are. I'm sure that's still good. I think the numbers may have not been as aggressive, but the demand is just there. It just keeps coming. And what that tells me is that technically the challenges are just enormous. And once there are challenges, then it needs people like yourselves to do the solutions, right? That's the optimistic me that talks about why this industry is still a good place to be in. It's up to you to go figure out where's the problem that you want to solve, either for a big company, a little company, or for your own company. That's your choice. Or for research, right? Any of those are possible. Okay? I'll give you some more examples. Here's an automotive field. You know, if you look at the numbers, this is from very recent information, just from last week. I don't know how many of you drive an electric car or a hybrid car, but the electronic content of automobiles just keeps going up. If you look at an average vehicle, I think the data I saw was $350 this year for electronics. For semiconductors, about double that for electronics. And if you look at a hybrid vehicle, it's about $600 of semiconductors. If you look at a luxury vehicle like a Mercedes, it's about $1,000. That's pretty significant content. Now, somebody has to design those chips, somebody has to make them, somebody has to test them, somebody has to make sure they work in the system. And when you get in and your phone doesn't connect, you get irritated as a user, right? So if you're the one that's designing that, you got to make sure that that thing works, right? The software works, the hardware works. Somebody has to guarantee it. It's not anybody else. It's you now, right? If you're in the space. So, I mean, you can look through this. Lots of different places where you have content in the ignition system, in the body, in the safety systems. And this is just a regular automobile. For an ADAS, automatic driving system, that's even more interesting. Okay, so if you take a simple example, I think I might have shown this before. If you take your navigation system, I think this is an example from Chrysler or Hyundai. I think both of them are same. There's the screen here. Behind the screen, there's a board and a little box that has all these chips in it. Now, who makes these chips? It could be Texas Instruments, could be Renesas that makes the microcontrol unit, the power management IC. So there were some people from HKUST that were talking about, if you have a better power management chip and you find the customer is really interested in yours and TI cannot make it, then that's an opportunity then for a startup. So that's how you come up with what are they doing today, what's a new solution that you offer. Now, having said that, I would say that in a situation where there's a big gorilla like a Texas Instruments that's already doing the chip, and you come up with one little enhancement, that may not be enough impetus to do a startup. That's where the experience would come in for somebody an advisor that could come help look at this. If it's something brand new that you're doing the application, by all means, right? So you got to do a careful assessment whether your solution is worth putting the investment to do a startup. The second part of the electronics here for that navigation system is the power unit, and there is the OMAP processor. That's the old Texas Instruments based device. Again, microcontroller unit. It's got the gyroscope and blah blah blah. You can see that. So again, if you're in this space and you're doing some background, whether it's the iPhone or whatever, there's all kinds of things you could do. I do want to cover the value chain. I think I hinted at this earlier. Let's say you are, there's a product provider here, and let me jump ahead actually. So let's say this navigation system provider, whoever that is, they have suppliers. So in this case, the OMAP Texas Instruments is the provider, so product provider is supplier, and they have their own supplier, right? And on the other side, there's a customer that buys it, and then there's a customer's customer. So this makes the value chain. In this case, this would be the navigation system. Mercedes might be the customer, and you might be the customer's customer here. Why is this important to know? Is because if you end up starting your own business and you're providing something, let's say a chip, let's say you decide to make this box, you've got to know what your customer is, and you've got to offer to the customer a solution that the customer must have. That's the importance of understanding the value chain. If you look at a smartphone, HTC or Huawei is a phone provider, and they buy the chips from Qualcomm, and Qualcomm is their supplier, and then Qualcomm has their own suppliers. So, you know, there could be multiple layers deeper than this also, but I just want to introduce the concept that you need to get familiar with where you fit in the value chain. Now, if you become an analog engineer at Texas Instruments, in your engineering job, you're probably not required to know this. But you, the broader person, probably should know, you know, what are you designing, who's buying it, why are they buying it? They're good logical questions. the more you do that, the more habit you get into to broaden your own horizons. Okay, so overall summary here, I think there's a prime market for all kinds of innovative solutions. Who's going to actually do the solutions? There's obviously the big gorillas, the powerhouses, the Intel, Samsung, Qualcomm, memory providers. They've got huge number of people that are doing designers. They'll probably hire you to become part of that team, which is okay, right? That's how the industry works. There are also other technology giants, like I mentioned, GE, the automobile manufacturers, pharmaceuticals, all kinds of players that their mainstream business is not electronics, but they use electronics. So those are places where you could go work, and they probably do need your kind of talent. So that's another possibility. You can also go work at specialty companies that are fabless IC companies. Remember I gave you an example for this cable provider. Etron is a company in Taiwan, for instance. They are a provider of chips that go into something like this. They could be this fabless IC company that provides solutions, or it could be you as a startup. So all of these will coexist, right? It's not that there's only a startup will do it or only these guys will do it. Just when we get to the startup piece, I'll tell you also is don't go head to head with a big gorilla like the Qualcomm. If Qualcomm's going to be shipping a chip, don't get into the startup business to compete with them right away, right? In fact, if you were a startup and you walk into Apple and say, hey, I got this greatest analog IC chip, please buy the chip from me, they won't even talk to you, right? You're a startup. You've never done a startup before. So don't go playing with the big gorillas when you're a little tiny person, right? So again, how you identify your market is very important. Bottom line of market drivers, I think the market drivers are huge. There's all kinds of opportunities available. And I think, again, that's what makes this whole business exciting, and it feeds on itself. There's a demand. The industry can provide chips that meet the functionality, that meet the cost requirements, help the customer reduce their cost, and provide more functionality. That's how this whole cycle just keeps going on and on and on. So we are at 20 minutes to 3. You folks ready for a break? You want a break? How about a 15-minute break? Good? Nobody has asked questions. This is the even more exciting part, is the opportunities, right? So.